Dangling pointer versus memory leak. How do they differ? Imagine working on a program and suddenly it crashes or behaves strangely. Sometimes the cause is a tricky memory problem. Today, we're going to explore two common issues: dangling pointers and memory leaks. They sound similar but are quite different. Understanding these can help you fix bugs faster and write better code. Let's start with a dangling pointer. Think of it like a bookmark left in a book that has been torn out. The pointer still points to a memory location that no longer exists or is no longer valid. This can happen if you free or delete memory but forget to set the pointer to null. Now, if your program tries to use that pointer, it might read or write to invalid memory. This can cause crashes, data corruption, or unpredictable behavior. For example, if you return the address of a local variable that goes out of scope, your pointer is pointing to memory that is no longer valid. Dangling pointers are dangerous because they can silently cause problems that are hard to track down. Now let's look at a memory leak. Imagine you rent a storage unit and forget to empty it when you're done. Over time, the storage fills up and you run out of space. In programming, a memory leak happens when you allocate memory dynamically but forget to free it. The program still holds onto that memory, but no pointer points to it anymore. This means the memory is lost forever, even though it's still allocated. If your program keeps leaking memory, it can eventually run out of space, causing slowdowns or crashes. Memory leaks happen when you allocate memory with functions like malloc or new but neglect to free or delete it before losing all references. So, how do they differ? A dangling pointer is a pointer that points to memory that has already been freed or deallocated. It exists but points to invalid memory. A memory leak, on the other hand, is when memory has been allocated but is no longer accessible because all pointers to it are gone. The memory is still allocated, but your program can't use or free it anymore. They are related because mishandling pointers can cause leaks. For example, if you free memory but forget to set the pointer to null, you might end up with a dangling pointer. Conversely, if you lose track of all pointers to allocated memory without freeing it, you create a leak. But remember, they are opposite problems. Dangling pointers point to invalid memory, while leaks involve inaccessible but still allocated memory. From a debugging point of view, fixing dangling pointers involves making sure you set pointers to null after freeing them. Also, avoid returning addresses of local variables that go out of scope. To prevent leaks, always free memory once you're done with it. Using tools like memory profilers or leak detectors can help find leaks early. Some programming languages offer smart pointers or automatic memory management, which can reduce these issues. Knowing the difference between dangling pointers and memory leaks helps you identify bugs faster. Fixing dangling pointers keeps your program stable, while preventing leaks saves memory and improves performance. Both are important skills for anyone working with memory management in software development.